Download this code from codegive.com, link in the description below. Code Reusability, a comprehensive guide. Code reusability is a fundamental principle in software development, aiming to minimize redundancy, improve efficiency, and enhance the overall quality of software. It involves creating modules, functions, classes, or patterns that can be used in multiple places within a single project or across different projects. In essence, it's about writing once, using many times. This tutorial will delve into the intricacies of code reusability, covering its benefits, techniques, challenges, and best practices, supported by code examples. Why is code reusability important? Reduce development time. Reusing existing code saves time and effort compared to writing the same functionality from scratch repeatedly. Improved consistency. When the same code is used across multiple locations, it ensures consistent behavior and functionality, reducing discrepancies and errors. Increased maintainability. Changes or bug fixes made to a reusable component automatically propagate to all places where it's used, simplifying maintenance. Reduced code size. Reusing code leads to smaller code bases, which are easier to understand, manage, and deploy. Enhanced reliability. Thoroughly tested and debugged reusable components contribute to higher software reliability. Better abstraction. Reusable components often encapsulate complex logic, presenting a simplified interface to the user, promoting abstraction. Techniques for code reusability. There are several techniques and strategies for achieving effective code reusability, each with its own strengths and weaknesses. 1. Functions, or procedures/subroutines. Description. Functions encapsulate a specific block of code that performs a well-defined task. They accept inputs, parameters, and produce outputs, return values. Reusability mechanism. By calling a function from different parts of the code, you reuse the logic it contains. Example, Python. Benefits. Simple, easy to understand, and widely applicable. Limitations. Limited in scope to the specific task it performs. May not be suitable for complex logic or data structures. 2. Classes and objects, object-oriented programming. Description. Classes are blueprints for creating objects, which represent entities with data, attributes, and behavior, methods. Reusability mechanism. Create multiple objects from the same class, each representing a different instance but sharing the same structure and functionality. Inheritance allows creating new classes that inherit and extend the properties and methods of existing classes. Example, Java. Benefits. Promotes modularity, encapsulation, and abstraction. Inheritance allows for creating specialized classes based on existing ones, enabling extensive reusability. Limitations. Can be more complex to design and implement than simple functions. Requires understanding of OOP principles. 3. Modules and libraries. Description. Modules and libraries are collections of functions, classes, and other code constructs organized into a single file or directory. Reusability mechanism. Import or include the module/library into your project to access its functionality. Example, JavaScript with Node.js. my_module.js. main.js. Benefits. Facilitates organization and reuse of large code bases. Libraries provide pre-built functionality for common tasks, such as data manipulation, networking, and UI development. Asterisk limitations asterisk requires proper module management and dependency handling. Can lead to dependency hell if not carefully managed. 4. Design patterns asterisk asterisk. Asterisk description asterisk design patterns are reusable solutions to commonly occurring problems in software design. They are not code implementations but rather templates for how to structure code to solve a specific problem. Asterisk reusability mechanism asterisk apply the pattern's principles and structure to your code to achieve a desired outcome. Examples include singleton, factory, observer, strategy, etc. Asterisk example, factory pattern in Python. Asterisk benefits asterisk provides proven solutions to recurring design problems. Improves code structure, maintainability, and scalability. Asterisk limitations asterisk requires understanding of the specific pattern and its applicability to the problem at hand. Can introduce unnecessary complexity if misused. 5. Generics, or templates. Asterisk description asterisk generics, or templates in C++, allow you to write code that works with different data types without specifying those types explicitly. Asterisk reusability mechanism asterisk the generic code can be used with various data types, providing flexibility and avoiding code duplication for different types. Asterisk example, Java. Asterisk benefits asterisk enables type-safe code reuse across different data types. Reduces code duplication and improves performance. Asterisk limitations asterisk requires understanding of generics concepts. Can increase code complexity in some cases. 6. Aspect-oriented programming, AOP. Asterisk description asterisk AOP focuses on separating cross-cutting concerns, example logging, security, transaction management, from the core business logic. Asterisk reusability mechanism asterisk define aspects that encapsulate the cross-cutting concerns and apply them to multiple parts of the code without modifying the core logic. Asterisk example, conceptual, AOP implementation varies significantly depending on language/framework. Imagine you have a function. You want to add logging before and after this method. Without AOP you would put the logging code in the process payment method. With AOP you can create an aspect that performs the logging logic and applies it to the process payment method without modifying that method. Asterisk benefits asterisk improves modularity and maintainability by separating concerns. Enables reuse of cross-cutting functionality across multiple modules. Asterisk limitations asterisk requires specialized tools and frameworks. Can be complex to implement and understand. Challenges to code reusability. Despite its numerous advantages, achieving effective code reusability can be challenging. Some common hurdles include 1. Not invented here, NIH, syndrome asterisk. Asterisk description asterisk developers are reluctant to use existing code, preferring to write their own solutions from scratch. Asterisk solution asterisk promote a culture of collaboration and knowledge sharing within the organization. Encourage developers to explore and evaluate existing solutions before writing new code. 2. Lack of standardization asterisk. Asterisk description asterisk inconsistent coding styles, naming conventions, and documentation make it difficult to understand and reuse code. Asterisk solution asterisk establish and enforce coding standards, naming conventions, and documentation guidelines. Use code linters and formatters to ensure consistency. 3. Tight coupling asterisk. Asterisk description asterisk code that is tightly coupled to other parts of the system is difficult to reuse in isolation. Asterisk solution asterisk design code with loose coupling in mind. Use interfaces, abstract classes, and dependency injection to reduce dependencies. 4. Overgeneralization asterisk. Description attempting to create overly generic components that can handle a wide range of scenarios can lead to complex and difficult to use code. Solution focus on creating components that address specific needs. Use more specialized components instead of trying to create a single one-size-fits-all solution. Apply the Yagna, you ain't gonna need it, principle. 5. Poor documentation description without adequate documentation, it's difficult to understand how to use and integrate reusable components. Solution provide clear and comprehensive documentation for all reusable components. Include examples of usage, API descriptions, and potential limitations. 6. Complexity and abstraction description overly complex code, even if reusable, can be daunting for others to understand and adapt. Excessive abstraction layers can also hinder reusability if they obscure the underlying logic. Solution strive for simplicity and clarity. Use appropriate abstraction levels, but avoid over-engineering. Write clean and well-commented code. 7. Maintenance and evolution description changes to a reusable component can have unintended consequences in other parts of the system that depend on it. Solution establish a robust testing and versioning strategy for reusable components. Use semantic versioning to indicate the impact of changes. Implement backward compatibility whenever possible. Consider using feature toggles or flags. 8. Organizational silos description different teams within an organization may develop similar functionality without knowing about each other's work. Solution promote communication and collaboration across teams. Establish a central repository for reusable components. Conduct regular code reviews and knowledge sharing sessions. Best practices for code reusability. To maximize the benefits of code reusability, follow these best practices. 1. Plan for reusability from the start. Consider reusability during the design phase, not as an afterthought. 2. Identify common functionality. Analyze the requirements to identify common tasks and functionalities that can be implemented as reusable components. 3. Design for modularity and loose coupling. Create components that are independent and have minimal dependencies on other parts of the system. 4. Write clear and concise code. Use meaningful variable names, comments, and consistent formatting to make the code easy to understand. 5. Provide comprehensive documentation. Document the purpose, usage, parameters, return values, and potential limitations of each reusable component. 6. Implement robust testing. Thoroughly test all reusable components to ensure their correctness and reliability. Use unit tests, integration tests, and end-to-end tests. 7. Use version control. Use a version control system, example Git, to track changes and manage different versions of reusable components. 8. Establish a code review process. Have other developers review the code to identify potential issues and ensure adherence to coding standards. 9. Promote collaboration and knowledge sharing. Encourage developers to share their knowledge and collaborate on the creation and maintenance of reusable components. 10. Use existing libraries and frameworks. Leverage existing libraries and frameworks whenever possible to avoid reinventing the wheel. 11. Adopt standardized interfaces. Use standard interfaces, like those provided by a framework or language, so that components are easily swapped and integrated. 12. Follow the solid principles. These principles of object-oriented design will help make your code more maintainable, extensible, and reusable. 13. Refactor regularly. Continuously refactor your code to improve its design and reusability. Identify opportunities to extract common logic into reusable components. Conclusion. Code reusability is a vital principle in software development that contributes to faster development cycles, improved software quality, and reduced maintenance costs. By understanding the various techniques for achieving code reusability, addressing the common challenges, and following the best practices outlined in this tutorial, you can significantly enhance the efficiency and effectiveness of your software development efforts. Remember that code reusability is not just about writing code once, it's about creating maintainable, scalable, and reliable software that can adapt to changing requirements over time.